right, so do you remember multiplying fractions? Okay, so like if I multiply 2/3 times, say, 5/10, there were two ways I could go about this. I could multiply first and then reduce, or I could reduce first and then multiply. Okay, so if I multiply first, I just multiply straight across, and I get 10 over 30, and then 10 and 30 will both divide by 10. Oh, I shouldn't have put 5/10. That's a bad example. Okay, hold on, I'm changing my example. We're gonna make it 5/8. Because 5/10 would already reduce, but okay. Same idea though, we multiply straight across, and instead of getting 10 over 30 this time, we're gonna get 10 over 24. And 10 and 24 will both divide by 2. So I can reduce that and I get 5 over 12. Or you can do what's called cross-canceling. And what I do is I compare the 3 and the 5 and the 2 and the 8 and see if they have anything in common. 2 and 8 have a 2 in common. So I divide each of those by 2 and I get a 1 and a 4. Then I multiply and I get 5 over 12. Now, when you're multiplying fractions, it doesn't really matter which one you do first. If you reduce first, you're dealing with smaller numbers than if you multiply out first and then reduce. But when we start talking about multiplying rational expressions, at the beginning when we're doing like the first ones we simplified where it's like just a monomial over top of a monomial, it doesn't really matter. Multiply first and then reduce, that's okay. But when we get to like the more complicated ones where you have polynomials on top of polynomials and you're multiplying those, it is an incredible time saver to reduce first. So you factor everything first, you cancel out anything that matches, and then you multiply together. It saves a lot of time and a lot of work. So in that case, this is the better option. So what we want to do is, if we look at the monomials, like let's say for example, oh I don't know, number 1 on the 3rd page of your homework packet. I look at this. This one's not actually that great. I'm going to look at the 59 and the 33 and say, okay, do they divide by anything in common? 33 divides by 3 and 11. 59 doesn't divide by either of those. So they have nothing in common. But they both have an n in common, so I can cancel that out. And then I look at the 80 and the 99 and I ask myself if they have anything in common. 80 divides by 2 and 4 and 8 and 10. 99 divides by 3 and 11 and 9. So they don't have anything in common either. So this problem kind of stinks. And I'm actually going to have to multiply 59 times 80 and 99 times 33. So because I figured out beforehand if there was anything that these crosses had in common and there wasn't, I already know that this isn't going to reduce. So I don't have to go trying to find things that will go into both 4,720 and 3,267. That's just going to be the answer. and I'll be done. That's because I tried to reduce first. If I hadn't tried to reduce first, I'd have to go looking for things to see if there was anything that could reduce those two. And I would waste a lot of time because I would be trying to find a whole bunch of stuff that maybe they had in common and they don't have anything in common. And it's easier to figure that out in the smaller numbers than the larger numbers. Does that make sense? No, 5 plus 9 is 14. Remember the rule for dividing by 3 is you add the digits together, and if your sum will divide by 3, then the whole thing will divide by 3. So since 5 plus 9 is 14, it won't divide by 3. Anything that's even, of course, divides by 2. If you add the digits together and the sum divides by 3, the whole number will divide by 3. If the last 2 digits of a number divide by 4, the whole thing will divide by 4. If you can divide it by 2 and 3, it'll divide by 6. So even and you add up the sum divides by 3. 9's the same rule as 3, except you add it up and you can divide by 9. And then 5, of course, it ends in 5 or a 0. Those are the quick rules. There's not really a rule for 7 or 11 or, 10 ends in 0. The most useful ones are the 2 and the 3. Because, 6 and 4 both divide by 2 anyway, so you could just divide by 2. 9 divides by 3 anyway, so you could just divide by 3. Numbers like 7, you have to just try. 11, you have to just try. 13, things like that. Let's look at number 3. Okay, the first thing I'm going to notice on this right away, 51N, thank you, is that 93 and 21 are both going to divide by 3. So I'm going to go ahead and do that right away and simplify this one so I can have even smaller numbers to work with. If I divide 93 by 3, I get 31 and I get 7. Okay, and then when I look at 34 and 51, I notice they both have an N. So I can get rid of that N right away on this one. 51 will divide by 3, but 34 won't. So I'm going to go ahead and rewrite this. And then I'm going to see if I can cancel anything in these directions. 31 doesn't divide by anything. 51 will divide by 3, but 31 doesn't, so I can't cancel there. 7 and 34, well, 7 only divides by 7. 34 doesn't divide by 7, so I can't cancel anything further. So now I'm going to have to do the straight multiplication. And then 7. And then don't forget your N. So sometimes you can cancel inside the individual fraction and then multiply. Sometimes you can cross cancel and then multiply. Sometimes you can do both. Big thing, so we can, like I said, up and down you can reduce, or you can reduce in an X, this way and this way. By reducing first, though, what I did is I eliminated the need to go looking for common factors in the large numbers, which can be time consuming. Dealing with the smaller numbers, which were easier to find the common factors in, saves me time and work that now I don't have to do over here with these bigger numbers trying to find things they have in common. And if I hadn't reduced this at all first, well, we would have done 93 times 34 and then 21 times 51, so we've had really big numbers over here to try to find these commonalities in. Does that make sense?
Yeah, I just figured your answer was wrong, so just follow what you're doing.
Oh, well, I didn't do the multiplication. I was taking your guys' word for it. Here, hold on, I'll double check it.
I just like looked up and saw it, and I was like, wait a minute.
31 times 34, that's good. And 51 times 7, that's good.
Now, what about number 2?
Okay.
46 seconds.
Well, that's when we, if you look in there, if there are any other n's that can cancel, you cancel. If there's not, you just leave them.
Oh,
okay. Okay, let's go to with polynomials. Okay. I want to use chalk color. All right, if we look at, let's say, number 8. Okay. What I want to do is I want to look across the whole numerator, like all of this together, and all of the denominators, and if there's anything in any of the numerators that'll cancel with anything in any of the denominator, I'm going to cancel it out. So this n plus 4 and that n plus 4 will cancel each other out. This n minus 3 and that n minus 3 will cancel each other out. I have a 7n squared here. I have n plus 8 and n plus 6. Those don't match. Nothing cancels. So after you cancel everything that can cancel, okay, so you cancel everything that matches from the top to the bottom, right? So if I had an n plus 4 here and an n plus 4 here and they're both on the top, they don't cancel. They can only cancel top to bottom. So once you've canceled everything top to bottom that matches, you write down whatever's left. Yeah. Okay, so in the numerator, the only thing I have left is 7n squared. In the denominator, I have n plus 8 and n plus 6. No, you don't want to foil it because we're trying to make it the most simplified version, and the most simplified version is for it to be factored. So you don't have to do any extra work. You don't have to multiply it back together. You just leave it exactly the way it is.
So 10, how would we write that one? Because the n plus 4's cancel out. There's a 9 and the 9 R's. So we do 9 outside.
Hold on one second. I'll do that one next. Everybody got this one? Oh, no, not that. I don't want that. That. Okay, number 10. You have a 9 r plus 4 over r plus 4. And you have 9 r over 9 r minus 5. Yeah, your r plus 4s here and here will cancel. You can either cancel these 2 9s, or you can cancel those 2 9s. So you have one set of 9s you can cancel. You can cancel those. In the numerator, I've got a 9 and an r left. Over r minus 5, yeah. Yeah, you can cancel either these 2 or you could cancel those 2. It wouldn't make a difference. You'd still end up with 1 9 left. Okay, now sometimes you've got a little more work to do. Actually, you know what? I'm going to do this on the next page to make sure we have enough room. So I have to factor this first, and I'm going to factor this if I can. So I'm just going to look and see if there's anything I can factor between 24 n to the third and 64n squared. Sorry, I left off the 2. See, 24 and 64 have an 8 in common. So I'm going to take out an 8. And they have 2 n's in common. So I'm going to take out 2 n's. And I'm going to be left with 3n minus 8. Now I'm going to come to my next fraction. I have a 9n and a 24, and those have a 3 in common. So I'm going to take the 3 out, and I'm going to be left with 3n minus 8 over 7n. My 7n's will cancel, and my 3n minus 8's will cancel. And I'm left with a 3 in the numerator and an 8n squared in the denominator. Now, if, hypothetically, everything in the numerator canceled, and then you still had something left in the denominator, you always put a 1 in the numerator if there's nothing left. Just, it's a placeholder. Let's look at 16. Okay, I'm going to factor a 20 and an a out of this numerator. And I'm going to be left with a minus 5. And I have a minus 1 and a 1. And 16 and 80 will both divide by 16. And there's 3 a's here and 2 a's there, so I'm going to take 2 a's out. And we'll be left with an a and a minus 5. The a minus 5s will cancel completely. Oh, sorry. And then when I look at this, I have a 20 and a 16. Those will both divide by 4. So that leaves me with a 5, and that leaves me with a 4. And I have 1a here and 2 a's here. So this 1a will cancel out one of those a's and just leave me with a single a. Do you guys all see that? Yeah? No? Okay. Then when I look and I see what all I have left in the numerator is a 5. And in the denominator I have an a minus 1 and I have a 4a. And it doesn't matter which order, you can write the 4a in front or the a minus 1 in front, like whichever you think looks prettier. Okay, I'm going to factor the numerator. It's trinomial, so I'm going to use my big giant X. But I've already done that one twice today, so I remember it. Okay. 10 and 100 both divide by 10. And then 45 and 9 both divide by 9, and I'm left with 5 minus x. And then I go, wait a minute. I have x minus 5 up here, and I have 5 minus x down here. And they don't quite match, but they almost match. And the way I could make them match is to change their signs. So what I can do is I can actually make this 9 a negative 9, and that'll switch that around. Yeah, because I can pull out the negative 1, and it changes the signs of what's inside and makes the x positive and the 5 negative. Okay. Actually, I'm going to change that yellow line so you can see what I changed it from. Okay. Now that I've got that changed, this x minus 5 Let me think, hot pink. This x minus 5, and which x minus 5 you want to get rid of, the right or the left? Left? Okay. Those will cancel. This x minus 10 will cancel out with that x minus 10. It's going to be times negative 9. So I'm going to be left with x minus 5 over 10 times negative 9, but I can multiply those together, so I get negative 90. Now, we don't like negatives in the denominator. It's not a good thing. We don't like those in math, so just bring it out front. And make the 90 positive. Okay. It's just more proper. Like not worrying. Remember how to divide fractions?
But yeah.
Okay, there's keep, change, flip, which is KCF, which is like KFC except backwards, so it's not really chicken. Or that one always messes me up, so I always use copy dot flip. Or you can do the keep, change, flip. But whatever, when you take a fraction and you divide them, you leave the first one the same, so copy. Change this, so change or dot, and then flip that. Then you follow the multiplication rules. I like to cancel first, and then you multiply and you're done. Same thing with rational expressions. We're going to have the division, we're going to turn it into a multiplication, and then we follow the same rules that we just did with multiplication. So if we look on the 4th page of your packet, you've got dividing rational expressions. Let's look at number 2. Okay. When it is still division, you cannot cancel. Okay, so the first thing you want to do is turn it into multiplication. So I do 16n over 17 times 6 over 8n. Then you can cross cancel or reduce inside the line, however you want to do it. 16 and 8 will both divide by 8, and n will cancel an n. 6 and 17 have nothing in common, so I multiply 2 times 6 and I get 12, and 17 times 1 gives me 17. If you have a little bit more of a complicated problem, sorry. Okay, we do 4n over n minus 6 divided by 4n over 8n minus 48. So first, I'm going to copy dot flip. Second, I'm going to factor everything that I can. Okay, 4n and n minus 6 are not going to factor. 8 and 48 will both divide by 8. And then I have a 4n. Then I'm going to cancel things. 4n and 4n and 8, n minus 6 and n minus 6. Actually, at that point, just 8. It would be 8 over 1, but that just equals 8. So you can just write down 8. You don't need to keep the ones if they're in the denominator. It's only when they're in the numerator that you have to keep them. So you always want to flip before you factor, just to make sure you remember to flip. Okay. 7a squared is just that. Both of these have 2 a's in common and a 7 in common, so 7a squared times a plus 8. I need 2 numbers that'll multiply to make a negative 8, but add to make a positive 7, 7, 8, and a negative 1. So this is going to give me a plus 8 times a minus 1 over 2. Then I'm going to go through and cancel things that match. Those match. So I'll get rid of them. And I write down what's left. Oh, did you still need that one? Okay, so step 1, I'm going to flip it. Okay, now I'm going to factor 10, 42, and 36 will all divide by 2. So I'm going to take that 2 out first to make my factoring easier. Guys, shh. It's going to be 21 plus 18. Likewise, all of these will divide by 2. So I'm going to do that as well. And this won't divide by anything, so I'm going to have to factor that. 40 and 48 all both divide by 4. Sorry, they both divide by 8. Okay, 3b, 3 times 10 is 30. So I want 2 numbers that'll multiply to make 30, that'll add to make negative 13. So you have negative 10 and negative 3. So I'm replacing the 13 with the 3 and the 10 to make this a factoring by grouping situation. Where'd I lose you? Here? Because I was turning this 13 into the 3 and the 10 so I could factor it by grouping. I'm going to do the same thing with these two. Okay, I have 5 times 18 is 60, 90. So I need to multiply to make 90 and add to make 21. Okay, well 9 and 10 are obviously not 21. And 3 and 30 are obviously not 21. 9 and 10. 15 and 18. No, sir. 5 and 18. No. It's 23. 15 and 6. That's what it was.
the second one?
I'm doing this top one here, yeah. And then I'm going to do the denominator. 3 times negative 30 is going to give me that negative 90, and I need to add to make a negative 1. Yeah, I'm going to run out of space too. So factors of 90 that'll make a negative 90 that'll make a 1, negative 10, and positive 1, 9. Okay, so all I've done so far is convert these trinomials into a factoring by grouping. Okay. Now that I've got them into a factoring by grouping, I'm going to look at the first two of each and the second two of each separately. Okay, so I have this 2 that's just going to be hanging out there. That can't go anywhere. 5 and 15 will both divide by 5. And they have a b in common. So I have a 1b left and a 3. That's from this section right here. And then 6 and 18 have a 6 in common, and I'm left with b and 3. Okay, now what I'm going to do is I'm going to skip down. So we're still working on this same numerator. Okay, the 2's hanging out. I have a 5b plus 6 from here and here, and a b plus 3. So could you follow the numerator? Okay. Okay, now I'm going to go with the denominator. The 2 is still hanging out. 3b and 9b, there's a 3 and a b in common. So I have a b left and a 3. And I have a negative 10 and a negative 30. That has a negative 10 in common with a b and a 3. So from this denominator, I have that 2. I have a 3b minus 10 from here and here, and a b plus 3. From this numerator, this 3b squared and this 3b, I can take a 3 from, and a b, and I'm left with b minus 1. And from this, I can take a negative 10 and get a b minus 1, which will give me 3b minus 10 and b minus 1. And then the the denominator stays the same. Once everything's completely factored, I can go in and start canceling things that match. And what I have left after all that is something very small.